Using Excel sheets for SQC monitoring. As we have discussed earlier, before we make an LJ, we have to get the values to assign on the charts. For this, we have to do parallel testing. This is the first concept explained in the video, how to use an Excel sheet for parallel testing calculations. After doing parallel testing, we have to use the values obtained to plot LJ charts. This process is explained in the second half. Parallel testing. Whenever a new QC lot is to be used, we have to do the parallel testing as said in the previous videos. Let us see how to do the calculations on an Excel sheet. Open a new Excel file, select a sheet and name it parallel testing or any name you choose to identify it thus. Label the top of the sheet with the lot numbers as shown. We are assuming here that both the lots were received together and being verified together. Also write the expiry date. Mark rows as shown. Main headings need being date, parameter, level, stated mean, stated range, and stated SD, all obtained from the QC insert. Mark rows for all analytes of interest for each level of QC. In the example, glucose, urea, and creatinine are shown for 2 levels, as generally routine chemistries have 2 levels of QC. Continue for all analytes the quality control is being used for and depending on the tests available in your lab. Fill in available data from the QC insert as shown for glucose. Mark out 20 rows as shown. Enter values of the 20 runs. Enter the dates you have done the runs. Here, we are assuming you have done 1 run per day. In the numbering column, below the run numbers, mark 4 rows as mean, SD, upper range that is plus 3 SD and lower range that is minus 3 SD. Now select all cells under L1 of glucose and go to sigma on the toolbar and click on average. Alternatively, insert equal to symbol, type average, open bracket, select the cells from run 1 to 20, close bracket and press enter. The mean value is calculated by the system and value appears against the row which says mean. This is the mean for glucose L1 for 20 runs. Now, go to the box below that says SD under glucose level 1 and insert an equal to symbol, type sddev.s followed by an open bracket. Again select cells having values from run 1 to 20, close bracket and press enter. Standard deviation shows in that box. So now you have observed the mean and SD. You can reduce the number of decimal places like this. Select the two calculated numbers. Go to decrease decimals on the toolbar. In the case of glucose, as we do not report patient samples in decimals, we can take out the decimals fully. For upper range that is plus 3 SD, insert equal to, click on the mean that we just calculated, click plus and an open bracket, press 3, press asterisk, click on SD that we calculated, close bracket, press enter. The upper range appears. For lower range, insert equal to, click on the mean, click minus, add an open bracket, press 3, press asterisk, click on SD that we calculated, close bracket, press enter. The lower range appears. You can now drag the formula to automatically calculate the mean, SD, upper and lower limits of all analytes by doing this. Select all the 4 rows where we have inserted the formula. Go to the bottom right where a plus sign appears. Keep the cursor pressed and drag this plus along the bottom of the last row to wherever you have fed your inputs. Your values for mean, SD, upper and lower limits of all analytes appear. In some boxes, error code #div by 0 is seen. This is because the formula has been put in and the data is missing. When you put data in, formula will work and your mean, SD, etc. will show on your worksheet. You can see in the example that the values for urea level 1 are entered and the calculations are done automatically. Plotting LJ charts. Now that we have obtained the required values to plot the chart, let us proceed with plotting. It is convenient to use one sheet for each month and also plot the different levels near to each other to monitor within run outliers. Please go through the earlier videos to understand the concepts. But before we do that, let us look at these numbers once again. We already know that we have to assign the upper limit as mean plus 3SD and lower limit as mean minus 3SD. Since we have adjusted the decimals, mild discrepancies would be there to allow a neat graph. This may be adjusted. In our example, we are changing L1 lower limit as 89 and L2 both limits are changed by 1 unit each to enable easy graphing. 101 minus 3 into 4 is equal to 89 and 250 plus and minus 18 will be 268 and 232. Now, we have these numbers for our parallel testing for L1 and L2 of glucose controls. Let us transport these values to the sheet number 2. These numbers become your assigned values. Assume we are going to start using these charts from February onward, so let us call this sheet Feb and transport these values there. Also, now that we are going to use these charts real time and we expect corrective actions, we should be having enough rows to do those. So, let us assign at least 40 rows for each analyte per month. Now, select all rows in that column starting from glucose 1 to serial number 40. Go to Insert, Charts, Line Graphs. You may select any line graph. Here, we are selecting this option, Line with Markers, and click. A graph labeled Glucose 1 appears. Now, click on the y-axis to adjust the mean and SD as per our need. Select Format Axis option and click. Under Axis Options, select Fixed, not Auto. Against minimum, you assign the lower range values. Against maximum, you assign upper range. Against major unit, you assign the SD value. Against axis value, you assign the mean value. Click Close. You will see a neat graph for glucose level 1, valid for 40 runs, where the mean, SDs and range is assigned correctly. Continue the same for level 2 of glucose so as to enable simultaneous visualization. Please note that while formatting axes, errors can happen. There is nothing to worry, just reformat. With practice, this can be easily accomplished. So now you have both graphs that can be used real time and enable your equipment performance in a real time manner. Finding your observed mean, SD and CV. Before we input values and demonstrate the graph live, there are few more things that we need to understand about imprecision monitoring on Excel sheet. Let us go back to our numbers in Feb. You have allocated 40 rows for this month, taking into account the need for corrective actions. We will be entering daily values in these rows. You will also note the date in the column assigned for this. Whenever corrective actions are done, there will be more than one entry per day or run. Alongside the graphing, we also need to understand the status of mean and SD in real time. Let us call these our observed values for mean and SD. The graph will tell you the story mostly, but it would also be good to look at the developing numbers. The assigned values on the graph will stay fixed throughout the lot usage with regard to mean and SD. However, your dynamic observed values of mean and SD will talk about any shifting accuracy and increasing imprecision. Let us see how to do this. Make 3 entries at the end of your 40 rows for observed mean, SD and CV. Against observed mean under the glucose 1, insert equal to, click average, open bracket, select cells from run 1 to 40, close bracket and press enter. Since there is no value input at this point and only formula is present, you will see error code #div by 0. As values are fed in, the calculation will automatically be enabled. Go to the observed SD slot and repeat as we did in the parallel testing. Insert equal to, type stdiv.s, open bracket, select all 40 cells required, close bracket, press enter. Again, the error code div by 0 will appear as there are no current value inputs. Now we will go to CV. Insert equal to, click the box where we just inserted the SD formula, press / for divided by, press the box where we just inserted the formula for mean, press asterisk and input 100. Press enter. Again, the hash div by 0 sign will appear as there are no current value inputs. Drag the formula for L2 also, demonstrating the use of the Excel real time. Now, let us input some values and see the developing graph mean and SD. 8 values have been put in from Feb 1 to Feb 8 for both L1 and L2, and as the values are input, the graph develops. What do you see on 8th Feb? A 22S violation. As the graphs are seen simultaneously, this becomes readily evident. Now, go to the bottom of the rows and look at your observed mean and observed SD. The assigned mean for L1 is 101 and the observed mean is 102. Assigned SD is 4 and observed is also 4. In L2, assigned mean is 250 and observed mean is 254. Assigned SD is 6 and observed SD is 5. At this point, there is no significant error present. But by observing the graph and the developing values, any developing error will become evident. So, how about the CV percentage? As we learned in the earlier videos, CVs are very powerful indicators of method precision. And as it is expressed in percentages, the comparison becomes very easy. Month to month, parameter to parameter, lab to lab, lot to lot, and so on. Here, glucose L1 is showing a CV of 3.7% and L2 2.1%. This indicates the precision of the method, L2 being more precise than L1 at this point. The CV percentage should then be tracked on a monthly basis to allow quality monitoring of the lab, as CVs are very powerful quality indicators. An additional Excel sheet may be employed for this. Let us call this CV trends. In this example, let us see the last sheet for this. Using the formulated columns onward for other parameters. Once one parameter has been configured, we can copy-paste it to be used in other parameters. For other parameters in the same month, copy and paste as showed. Now, clear contents both from the heading as well as value inputs and repurpose for the next parameter, say urea. Clearing contents in heading with regard to glucose. Clearing contents in the value input sheet. A cleared reusable formulated set of columns. Inserting assigned data referring to urea 1 and 2. The formulae will be present in the copy-pasted version. However, graphs will have to be constructed as instructed earlier. The Excel sheet is very broad and will lend itself to including data of several parameters thus. However, the user may decide how many parameters they want to use on one sheet, carrying it forward to the next month. At the end of each month, or as desired by the lab, the data entry cells can be copied and pasted for using in the next month. Go to the upper left-hand cell as shown and copy the whole sheet. Go to the next sheet and clicking on the same left top corner cell, paste it on that sheet. Label the sheet March. Clear contents with regard to data inputs and dates from each parameter. Delete graphs and start afresh. The assigned values will stay the same as long as the lot lasts. The calculations of the observed mean, SD, CVs will still be available. However, regraphing will need to be done as explained earlier.